Since 2015, the viral infection called Zika virus has caused birth defects in more than 5,000 Brazilian children, and it threatens to continue spreading to others. HIV is another viral infection which slowly kills about 1 million people every year, or about one person every 20 seconds. Measles is another virus, and when I was a child, it spread to my neighbourhood and it infected my dad, and it made him so sick that he was at risk of brain damage. And it's plausible that it got there because of people who refuse to vaccinate. My name is Hamish Todd, and this is erythrovirus, and I invite you to examine it using your mouse or your finger. Now, erythrovirus is something that a lot of us will get when we're in our childhood, and it'll usually just give you this harmless rash. However, if erythrovirus infects a pregnant woman, then it can cause miscarriage, and so scientists have created this model of it. The shapes that it's made of, you can see, are called proteins, and if we add a bit of colour to the proteins, by rotating it you should be able to see that every protein is exactly the same shape, and that every protein is clustered together with its neighbours in exactly the same way. You can unpause me at any time when you want to move on, by the way. Now, these are images of some other viruses, and they are very much worth looking at because a virus's construction can tell us a lot about its behaviour. But virus construction can also tell us a lot about humans, because as strange as it might be to hear, humans have imitated viruses many times throughout history in our designs. We've designed golf balls that look like viruses. We've designed buildings that are structured like viruses. We've created wonderful works of religious art, which, in a subtle sense, resemble viruses. And the strangest thing about all of these things is that they came around before anybody had even seen a virus, let alone before anybody had consciously thought to imitate one. Before we can understand how that happened, though, we need to see how viruses infect us. So, for this virus to spread, it first needs a cell, which is a much larger and more complicated thing than a virus. What can end up happening is that the cell mistakes the virus, say, for a piece of food, and will absorb it. And that causes the virus to dissolve, and what the cell might like to do with it would be to digest the individual pieces of the virus. But instead we see something else happening. Copied pieces of the virus start appearing inside of the cell, because the cell's reproductive machinery is mistaking certain parts of the virus for parts of the cell. Here's an infected cell that's uncontrollably reproducing virus proteins highlighted in pink. Now we can start to see why this shape helps viruses. We are going to pretend that these pieces of plastic are virus proteins. Proteins are all the same, and so are these. And virus proteins have the ability to fuse together if they collide, so these things have magnets in them. Now, inside of the cell, the virus proteins get shaken around forcefully and randomly. So we're going to simulate that. And we have a virus. Now, humans are complicated, and so we have to be reproduced slowly. But viruses are simple and very, very symmetrical. Because they take on a symmetrical shape, they can be made out of identical pieces, and these identical pieces can fuse together from any angle, and they can build up in any order. Soon you can have a cell that's full of the virus's offspring, and that cell will split open and die, potentially killing the person who the cell belongs to, while the viruses spread to other cells and begin the process again. So we have seen that erythrovirus can reproduce very quickly because it is highly symmetrical. But not all viruses are like erythrovirus because there are many other very symmetrical shapes out there. We are going to look at a few different viruses, and you can just click on whichever one it is that you'd like to hear about first.